This is a brief introduction to volcanoes. Let's start off with our Earth. There are 4 layers inside the Earth. These are the crust, the mantle, the outer core, and the inner core. The crust is around 50 kilometers deep, has temperatures of up to 500 degrees Celsius, and is solid rock. The mantle is 2,850 kilometers deep, has temperatures between 600 degrees Celsius and 4,000 degrees Celsius, and is molten rock. The outer core is 2,260 kilometers deep, has temperatures between 4,000 degrees Celsius and 5,000 degrees Celsius, and is liquid metal. The inner core is 1,210 kilometers deep, has temperatures between 5,000 degrees Celsius and 6,000 degrees Celsius, and is solid iron. Moving on to plate tectonics. The Earth's crust is broken into huge tectonic plates that float and move about on the molten rock in the mantle. The continents are thought to have moved to their positions in a process known as continental drift, which is the movement of tectonic plates. Landforms such as mountains and ocean trenches are created as the plates move apart or collide. For example, the Himalayas were formed between 56 and 70 million years ago, when India collided with Asia. There are 15 tectonic plates. They are the African plate, the Arabian plate, the Antarctic plate, the Iranian plate, the Eurasian plate, the Philippine plate, the Indo-Australian plate, the Pacific plate, the Juan de Fuca plate, the North American plate, the Coscos plate, the Nazca plate, the Caribbean plate, the Scotia plate, and the South American plate. There are 3 types of tectonic plate boundaries based on the movements of the plates: divergent, convergent, and transform boundaries. Tectonic plates are constantly moving at different speeds and in different directions. Divergent boundaries occur when adjacent tectonic plates move away from each other. The mid-oceanic ridges and rises are the most common spreading plate boundaries. Convergent boundaries occur when plates collide into each other and one plate is destroyed as it subjects under the other. There are 3 types of convergent boundaries: oceanic, continental, and oceanic continental. Lastly, transform boundaries occur when plates slide past each other, neither creating nor destroying the plates. This movement produces earthquakes. Plate boundaries are named according to the way the plates move in relation to each other. Divergent boundaries involve pulling apart, convergent boundaries involve crashing, and transform boundaries involve side sweeping. Let's move to the formation of eruptions. Firstly, a volcano forms due to the magma emerging through an opening or weakness in the ground. When pressure builds up, the volcano erupts. Volcanoes consist of a vent where magma is extruded from underground, and a crater at the top where material such as lava, steam, pumice, and volcano bombs are ejected. The terms active, dormant, and extinct are used to describe a volcano's stage of activity. Active is used to describe a volcano that is erupting or has shown signs that it may erupt in the near future. Dormant is used to describe a volcano that is not currently active but may become active in the near future. And finally, extinct is used to describe a volcano that is no longer active and is unlikely to erupt again. The most obvious volcanic landform is the volcano itself. Volcanoes have a variety of shapes and sizes, but there are 4 main types. The shape of the volcano depends on the type of lava that is erupted. Volcanoes that erupt runny lava tend to have broad, flat sides, which are shield volcanoes. Those that erupt thick treacle-like lava tend to have much steeper sides, such as dome volcanoes. The amount and type of ash that is erupted. Heavy material like volcanic bombs settle close to the crater, whilst lighter ash is carried further away. Volcanoes that are built up through falls of ash are steep-sided cinder cones. And finally, the combination of lava and ash. The most common type of volcano is one built up of both ash and lava, called a composite volcano. There are many other landforms created by volcanic eruptions, such as crater lakes, geysers, calderas, and fields of ash deposits. Following up is a description of the most common ones. A fissure volcano has no central crater and giant cracks open in the ground, which expel vast quantities of lava that spread far and wide to form huge pools that cover almost everything round. A shield volcano's shape is formed by thin lava that spreads widely before cooling and hardening. A dome volcano's shape is formed by thick lava that cools and hardens rapidly. An ash cinder's volcano's shape is formed with layers made up of heavier rocks near the vent and cinders and ash towards the edges. Composite volcanoes are bodies of igneous rock formed when former channels of magma had cooled, forming the shape. A caldera's volcano's shape is formed by collapse in gigantic eruptions that spew volcanic rocks out in all directions. Geysers are hot springs usually near the surface that prevent water from circulating free to the surface where heat would escape. A volcanic plug's shape is formed when magma hardens within a vent on an active volcano. A lava tube is formed by flowing lava which moves beneath the hardened surface of a lava flow. Hummocks are landslide on a volcano. And finally, pumice is a live volcanic rock that forms during explosive eruptions. It is like a sponge because it has a network of gas bubbles. A pyroclastic flow is high-density mixtures of hot, dry rock fragments and hot gases that move away from the vent that erupted them at high speeds. They destroy by direct impact, bury sites with hot rock debris, melt snow and ice to form lahars, and burn forests, crops, and buildings. They result from the explosive eruption of molten or solid rock fragments, or may also result from the non-explosive eruption of lava, when part of dome or thick lava flow collapses down a steep slope. A pyroclastic flow can travel at speeds typically greater than 80 km per hour. They consist of two parts, a basal flow of coarse fragments and a turbulent cloud of ash that rises above the basal flow. These flows can affect all combustible material to burn, destroy buildings, forests, and farmland, and cause death or serious injury to people and animals. A lahar looks like a mass of wet concrete that carries rock debris ranging in size from clay to boulders more than 10 meters in diameter. The name comes from the Indonesian term that describes a hot or cold mixture of water and rock fragments flowing down the slopes of a volcano and or river valleys. They are formed by intense rainfall during or after an eruption. Rainfall can easily erode loose volcanic rock and soil on hillsides and in river valleys. Lahars are linked with pyroclastic flows as they are both sudden surges of melting snow and ice. In fact, many of the largest and most destructive historical lahars are from pyroclastic flows, as well as surges, hot blasts, and hot rock avalanches. Volcanic eruptions can occur on a massive scale, causing death and destruction to properties, or they may only extrude hot gases. They may also have other side effects, such as landslides, earthquakes, and flooding. However, volcanoes are valuable to humans due to their magma, sulfur, spring water, basalt, tuff, and geothermal energy. Hotspot volcanoes form in the middle of tectonic plates directly above a source of magma located deep beneath the Earth's crust. Molten lava rises to the surface and erupts in a lava flow or fountain. A hotspot stays still, but the tectonic plate above it keeps moving. Let's do a few short case studies now. First off, Mount Etna. Mount Etna is a composite volcano. Its first recorded eruption was in 1500 BC. Since then, Etna has erupted at least 190 times. Etna erupts both from the summit craters and from vents away from the summit craters. Studies of Mount Etna's recent eruptions suggest that the volcano is becoming more explosive when compared with past events. However, the origins and behavior of Etna are hotly debated, no pun intended, and there is no agreement on the source of the magma or reasons for the recent changes in eruption patterns. Our second case study is on Mount Kilauea. Kilauea is an active shield volcano located in the Hawaiian Islands. The first eruption of Kilauea is estimated as 300 to 600,000 years ago. Its first recorded eruptions were in 1823. Its most recent eruption was the 3rd of January 1983. According to U.S. Geological Society, Kilauea erupted approximately 63 times between 1750 and 1982 and has been erupting ever since. Our final case study is on Chile's Calbuco volcano. This volcano erupted for the first time in over 40 years between the 22nd and the 23rd of April 2015. The explosions were so powerful that they sent waves rolling through the atmosphere above South America. In Europe and Great Britain, the volcano's effects included not only the coolest summer on record, but day after day of cloud-covered skies and above-average rainfall, which caused widespread crop failures, outbreaks of disease, and famine. Many things are being done to manage active volcanoes. Volcanologists predict the eruption of volcanoes by this process. Hundreds of small earthquakes are caused as magma rises up through cracks in the Earth's crust. Temperatures around the volcano rise as activity increases. It starts releasing gases. The higher the sulfur content of these gases, the closer the volcano is to erupt. Technology such as a seismometer is implemented to detect earthquakes and pick up the vibrations of the Earth. Thermal imaging techniques and satellite cameras are also used to detect heat around a volcano. Gas samples may also be taken, and chemical sensors are used to measure sulfur levels. There are 4 steps to prepare for a volcano eruption. 1. Create an exclusion zone around the volcano. 2. Being ready and able to evacuate residents. 3. Having an emergency supply of basic provisions such as food. And 4. Funds needed to be available to deal with the emergency, and a good communication system needs to be in place. Hope you learned something today, and thank you for watching this video. See ya!